In this video, we will talk about outliers or outlying observations. And typically, these are observations that look, when you plot the data, these would stand out. So these would not be with the rest of the cluster, but they would stand out because they have some kind of extreme value. These, typically when we think about random samples from nicely behaved population distributions, those typically would not have any outlying or unusual observations, okay, or very rarely would they have that. A nicely behaved or a normal if you think about a normal distribution, for example, right, a normal distribution is nicely behaved because it has thin tails, right? There's not a lot of observations in these that have extreme values, right? Most of the area, if you look at the area under the curve, most of the values are right here, okay? Very few are taking these extreme values. So thinking about that, if we don't encounter that, then this can happen, of course. If we don't encounter that, we need to have some kind of a method to deal with those outliers. In financial data, for example, which we'll cover next semester, there's a lot of extreme values. There are a lot of extreme values, and those tails are actually very fat. Okay, so here are very fat tails because there are extreme values that can occur in financial markets, for example. Anyway, data can be very messy, and sometimes researchers can, when they're inputting data or something, they can enter wrong values or switch between the different scales, proportions, or percents, and dollars and thousands of dollars and so on, right? So what do? We can encounter this data that's very messy. One way is to always inspect the data. So I've told you before that it's always good to visualize your data. I think you've done an exercise last week. This is very good because it gives you, the visualization is good because it tells you about, where are the clusters, what are the outlying observations, and things like that. You can also look at summary statistics like, min and max values, minimum, maximum values, medians, means, standard deviations, and even histograms, okay, just to see what the distribution looks like. And look for values that are very unusual, okay, so that's what we're hunting for here. And typically these unusual values would be many standard deviations away from the mean, right? So we're looking for, what is there in the tails of the distribution of that variable. Now, extreme values may not be always unusual, right? So while, we're seeing that this is unusual, but sometimes some members of the population can have quite different values from the rest of the population, right? If you were just thinking about, let's say, income data, you're going to have, a pretty normal distribution there, but then you're going to have, people who are going to be really low income and really high income. And if you were just looking at, those high incomes, there could be a really wide disparity there, right? Within the high income earners also, you could have very extreme observations for income. And similarly, for low income, right? What's considered low income could also be a range. So an outlier is a data point that seems fundamentally different from the rest of the sample. And the best way I can tell you is to visualize your data. And it's difficult for me to give you a precise definition about what do we mean by an outlier, and even do we even agree on what to do about it? But I'm going to show you some solutions perhaps. So whether you visualize it or you look at histograms or you look at min-max values, it is easier to determine if an observation is an influential observation. Okay, so this is something that we can do. If including an outlier significantly changes your estimates, then it's probably an outlying observation. So it's basically influencing your regression enough to change something about it. Okay, so ask this question: does excluding it change the OLS estimates in an important way, or does including it change OLS estimates in an important way? If so, then we must think hard about whether to include it or not. Okay, so sometimes different sets of estimates are reported, one with the outlying observations, one without, and you can have a discussion around that. But we do want to make sure that we understand that having influential observations or one influential observations may actually be a good thing, because it shows that we have more variability in our explanatory variables, which generally would reduce the variance of your OLS estimators. Right, so we're talking about the variance of beta hat. Okay, so as you have more variation in X, remember SSTX from long time ago, that influences the variance of beta hat. So as this goes up, the variance goes down. Okay, so that's the idea here.